Good morning, ladies and gentlemen. Thank you for the nice introduction. So I have to start my timer that I keep my timeline. Just a second. Okay, so don't be surprised if you hear a beep after 16 minutes, but I try to manage to keep the timeline. So once again, good morning, warm welcome as well from my side to the audience here. Great to see again so many people here in Bled. It's all the time an honor for me to give here a presentation. So I would like to talk about our product which we have developed in 2010 to support the asphalt industry to use more RAP in their asphalt mixes. So here's I would like to share our experience, what we have gained in Austria and in Czech Republic with this product. So the content, short introduction about I will talk about, then I will explain briefly the aging process, but really very brief because of the time. I will give an introduction about the idea why we have developed this product, and then the first test results from Austria and from Czech Republic, and then we will come to the conclusion and to the outlook. So in 2013, some of you might remember that a colleague of mine, Mr. Kammer, gave already a presentation about the product what we have developed, about the test section from Austria. So if somebody has some interest, you can read the article once again. At that time, we have presented a lot of asphalt mix test results as well. I would like to focus today more on bitumen test results. So what is the status quo and what are, I guess, the future challenges for all of us here in the room? So right now, across Europe, the idea of reusing RAP is becoming more and more important, and it's more and more frequently used. Started in Western European countries, I think it's already a common process. We started now in Austria to use it more frequently, and going to Eastern European countries, we see as well there that there's some more requests to get more information how to use RAP in asphalt mixtures. So in Austria, the amount of RAP is continuously increasing. So looking back in 2004, we talked about 1.2 million. Now we reached already 2 million tons of RAP, what we gain every year in Austria, which we have to reuse, or what we try to reuse on the highest level, not to waste the material, so try to reuse it on the highest level, meaning bring it back into the asphalt production cycle. The main driver behind was ASFINAG. So they started really, let's say, 9-10 years ago to request as well in their tenders the reuse of RAP. And that was one of the drivers why we developed our product, how we did it, which I will explain later on. And we have as well the driver of the construction product regulation, where there's as well the request of recyclable construction material. So, and we are a construction material, even bitumen or our asphalt materials, and that's very important for us. Luckily, our product is 100% reusable. That's really the good thing of our construction material. And as well, it's required that we think about sustainability with our products. Future challenges, and this will come very soon, is we see that there are some tendencies to put some waste material or secondary construction material in our asphalt roads, and I think here we should be quite careful. You can have a look on the APA website where they put as well a position paper on their website, how they see the use of waste or secondary materials in asphalt construction. And I think this will become a big challenge for us here in the room, how we will deal with this one, and then how we will deal with the challenge when we have to reuse these waste materials or secondary construction material again in asphalt recycling. So coming now to aging of bitumen, just to remind everybody here in the room, very simple. This knows everybody here in the room. When we talk about aging behavior on well-known properties, meaning penetration, softening, ring and ball, everybody knows penetration decreases, softening point increases, and the product is getting hard, getting brittle, and then we have the cracks on the road. So it's nothing new, just as a reminder. But we have detected this information, just to look on penetration and softening point, will not give you enough information about the RAP. You will fail if you just look on those two properties in the future. This I can promise right now. So I think you have to analyze your RAP materials in the future much more in details, that you know how much RAP and in which form you can use it in your asphalt mixes. So that's the reason why we have looked on DSR measures. So you see here the two properties, the G-star and the phase angle of the DSR method. So here you see typical curves of lab-aged 70/100. We choose 70/100 because that's the typical product what we use in Austria. And starting from the first line, the dotted line, that's a fresh product. Then you have the short-term aged product, and then the upper line shows you how the product is getting harder during the aging process. So the G-star is increasing, and the phase angle is decreasing because it's getting stiffer. So it's not really an elastic response from this material. It's purely due to the fact that it's getting more brittle during the aging process. So everybody thinks our wrap will behave in the same way, but you will see later on that's not the case. So as a comparison is our main PmB product, what we use in Austria. So it's a PmB 4580/65, and you see here the difference of the curve. For specifically the phase angle, if you look on this one, that's a typical PmB phase angle where you see the elastic components of the PmB and how it reacts, and you see as well the G-star, how it's stiffer on higher temperature. That's the reason why we have no ruttings if you use PmB. So keep some of these graphs in mind because you need it for later on to understand our test results a little bit better. So coming to the reason why we developed our product in the way how we did it, as I already mentioned, the starting point was that Asfalti came with the idea to use more wrap on the roads. So we said, okay, on the highways we use mainly PmB, so we have to design a PmB product which allows our customers to use wrap into the asphalt mixture. In Austria, we don't have really a lot of parallel drums. All mixing plants have the possibility of cold adding of wrap, so there's then the limitation with 20–25%. And we said, okay, we have to design a product which is fulfilling the technical requirements what we have, or boundaries what we have in Austria, and still to produce afterwards an asphalt mix which has minimum the same properties and the same quality if an asphalt producer would use 100% fresh material. So this is a curve what you have seen already before. So that's the long-term aged 70/100. And then we said, okay, how a wrap look like. So not only if we look on penetration and softening ring and ball. So here we have an example. When you only look on penetration, softening ring and ball, you would detect here in this case a 10/20 of the wrap. But you see that the DSR curves looks completely different. So you see a completely different phase angle of this material. So it's very low due to the brittle and the hardness of this product. So if you consider in your wrap usage only the 70/100 long-term age curve, you will fail because you see the wrap has a completely different behavior. As well from the G-star, it looks differently. So you have to do in the future careful analysis of your material that you know what you put in and how you have to react on this material. So we said we would like to get such a behavior of the material. So if you use wrap, you add some fresh binder, how the resulting material should look like. And this curve which you see here is a short-term aged 4580/65. So this is more or less the product which you, after mixing, you put on the road. And you would recover the binder, then you should come more or less to such a curve. And you see here on the phase angle the typical behavior, the typical shape of the PmB. So to get there, we said, okay, we might need such a product which has those properties what you see here on the red line. And if you mix it together with different amount, then you should come quite close to the green curve. So keep those curves in mind. For the next slide, so here you see the installation of the first trial section, what we did in 2010. You see the amount of wrap which was used on the surface layer and in the base layer, so 15% or 20%, the amount of fresh binder which was added, and the amount of air void. So it was done in Styria in Austria. So now here's some pictures after 9 years in use of this road. So you see nothing, luckily for us. So you see no cracks, no maintenance steps has to be done till now, no deformation, nothing. So it's still after 9 years in use in an excellent shape. Coming to some test results. So we recovered the binder after installation, and now this spring we also drilled some cores from this section just to see how the binder properties have changed over time. So coming back again to the well-known curve. So that's the curve of the wrap which was used in this trial section. This was the curve from the fresh PmB RC, which we have used at this trial section. So in those two were combined with up to 20%. This was the target curve to reach, which you can remember from the previous slides. And this was the result. So after installation, when we recovered the binder, you see the yellow curve. So we are quite close, or more or less there, what we would like to achieve. So even the G star is a little bit lower than the short-term aged fresh PmB 45, 80, 65, which is an excellent result. So it shows that the blending and the fresh material is working as we have expected, and as well the phase angle, you see it's really the shape of the PmB. Here you see the curve then after 9 years in use, so the blue one. So you see nearly no changes of the properties. So we still have more or less the same status quo of the PmB or of the binder, which is there. So nearly no aging of the material, which is really excellent. So we didn't expect it in that case. So that really stays like this one. But yeah, good for us and good for the road owners. So here a further graph, what we have seen not, so it's this gray area, which gives you an idea of where a PmB lays in, if you do a lab aging from fresh up to long-term age. So that's the upper curve. So in this, so usually we expect that the PmB during aging moves from this side to that side, and then you have to expect some cracking. Still, there is enough room from the blue side up to the end of this gray zone, so we expect no crackings on this road for the next 5-10 years. So here you see then the difference between 15% and 20% rep. So more or less it looks equal, so you see a little bit the impact of the higher rep content, so it's getting a little bit stiffer, but more or less the curves are equal even after 9 years. So similar curves so I showed before for the base layer. Here now for the surface layer. Again, similar results. Here we see already a slightly aging of the material, but nothing critical, nothing dramatical after 9 years. So if you would put all the graphs together, you would see that more or less the curves of the recovered binders look equal. Doesn't matter with 15 or 20% of rep, doesn't matter if it's from the base layer or from the surface layer. Here are some examples from Czech Republic. So we did here a trial in Domasov, it's the name of this city. Here in this case, 15% rep. You see here some pictures of the installation. And here after 4 years in use. So again, you see still very nice surface, no maintenance treatment was necessary till now, no cracking, no deformation. Here's the second trial section what we built, that's in another city. So again, here the pictures after 4 years in use. So it's same as in Austria on the other trial section. No maintenance step till now, no cracking, nothing has happened on these roads. So here's some test results from Czech Republic. This we did together with the Technical University in Brno. So here you see the well-known penetration softening point, what all of you know. So you see the first one is the fresh material, and then here we did a very, quite often some checking of the material. So after installation, after 6 months, 12 months, 24 months, and after 44 months. So and you see here on the penetration and softening point in ring wall, no changes. So since the beginning, they are more or less on the same level, which is excellent. And we did as well some DSR testing there, so same logic as before. Here we put the rep curve, what we know from Austria, because we didn't do DSR analysis of the rep which was used in Czech Republic. But more or less we said, okay, let's compare it with what we have in Austria. So here again, the fresh binder. This is the target curve to reach. So this we had after installation. So what we see here, the difference, you will see here on the phase angle. This looks differently than in Austria, which is telling us that the rep which was used in Czech Republic was different to the rep what was used in Austria. So the phase angle of this rep which was used in Austria was higher than the one in Austria. So it was not that stiff, that brittle, this rep material. This is our interpretation of this changing of the curve. So this was after installation, and now you see after 6 months, so nearly no changes, same curve, after 12 months and after 44 months, so after 4 years in use. So you see afterwards no real big changes of the shape of the curve from the DSR measure. So it seems the product stays the same as we have installed it, which is again an excellent result for us. And the same then for the product in Domasov. So similar shapes, similar results, which is excellent for us. So it seems it works pretty well as well with the materials there. But we have seen here it's really critical and important that you have a closer look on the wrap material which you're using, because it has an immediate impact on the results of the finished product. We did as well, there are some BBR measures of the recovered binder. As well, here you see still minus 20 degrees, which is excellent for the BBR testing. So we see a minor aging impact of the material at the beginning. So you see here the curve. So we see a slightly aging at the beginning, but now it's getting more or less stable. And we are still far above or around minus 20 degrees. So we would not expect here any problem with this trial section according to low temperature cracking. So rushing through the presentation, I think I'm still in time. So here what we did as well, we looked then afterwards because we did a lot of fatigue testing, stiffness testing as well with our PmB RC in connection with some wrap material. Here you see now the results for this pavement structure. So this is for close to the end, for 10 million load cyclists. And you can see here that's the calculation with 20% rep. So more or less we came to the same amount of load cycle which such a road can survive, which is excellent because that's important for the investors, for the road owners, that they see there is no negative impact if you do a proper mix design and if you use the right materials. So that's already the last slide. So a short conclusion summary, which you should keep in mind when you go out of this session. So you have seen pictures which has clearly proven that there were no maintenance step needed till now. So still all the trial sections are in an excellent shape. So you see that there's nearly no aging or a slow aging of the binder material which was used. So it's right now no problem up to 20-25% in cold adding. You get an excellent asphalt mixture afterwards, which has minimum the same performance as if you would use 100% fresh material. So it's in Austria already commodity product. So if on the highway section or somebody is using a wrap in connection with PmB, they are using this type of PmB for the asphalt mix. And you have seen as well with the pavement design that more or less you can achieve the same numbers of load cyclists. And then outlook, what we will do further is now to see how this material behaves when you go up to 40% of using wrap in a parallel drum. So we would expect that this is as well possible without any problem. I've shown it's important that you look on different properties, looking on DSR measures. So do careful analysis of your wrap if you would like to use it, specifically if you would do some higher amounts of wrap. And what we will look as well is the multiple recycling or reuse of these materials. So many thanks, and yeah, questions at the end of the session. Thank you.
Markus Spiegl, thank you for your presentation.